Alright, so we want to determine is the equation even or odd, sketch the graph, and verify using algebra. So we're using two different methods. So you can use your graphing calculator to help you. I think you should be able to kind of do it without, but if you can't, use your calculator. So I know this, the vertex is going to be at 2, -5, right? So 2, -5 is going to be 1, 2, 1, 2, 3, 4, 5. So I'm going to have a graph that looks like this. Okay, now to be even, it's got to be centered at the y-axis. So to be even, you have to have symmetry about the y-axis. And as you can see, this is skewed off to the right, so there isn't symmetry. So I definitely know it's not even. And it's not odd, because to be odd, odd has to have symmetry around the origin. Excuse me. And it has to be 180 degrees. Okay, so we know it's not even, we know it's not odd, so it's going to be neither. Now, to show this, what we do is we plug in f of -x, and then we did see what we get. So when I plug this in, I get -x minus 2 squared minus 5. Alright, so then essentially what we get here is we get -x, so this equals, this ends up being -x plus 2 squared minus 5. So in algebra, if we get, when we plug in -x, if we get x, if we get the same thing, it's even. If I plug in -x and I end up getting -x, opposite of the original function, then it's odd. If even doesn't happen and odd doesn't happen and I come up with something else, then it would be neither. Okay, so this is showing me algebraically that it is neither. Okay, now on this one, this is the absolute value and it says -5. So it's going to be 1, 2, 3, 4, 5, and I'm going to get a graph that does this. And this is symmetrical around the y-axis, so it's even. And then to show the algebra, we do f of -x equals the absolute value of -x minus 5. So then we get -x equals the absolute value of x minus 5. Now, because this is the absolute value of -x, this is going to be the same thing, right? Whether this is negative, this is always going to be positive, so it's going to be the same thing. And so since it's going to be the same thing, it's even. And so this is the algebra for that problem. For this graph here, we know the square root function is going to do something like this, right? So we know that to be even, it has to be symmetrical around the y-axis, which it is not. And so it's not even, it's not odd, it's neither. Oopsie, why am I doing that? It's not even, it's not odd, it's neither. When we look at the algebra, f of -x equals the square root of -x. Okay, so now this can only happen, this will only happen when x is greater than 0, greater or equal to 0. Or excuse me, I lied. This will only happen when x is want to say when x is, this will only happen when x is less than 0, less than or equal to 0, because you're going to end up getting a graph that's going to go like this. And that's obviously not symmetrical around the y-axis. All right, so the next graph is f of x equals negative 2x cubed. So when we look at this, where it's negative, so it's going to be over 1, up 1, 2, and then this is going to be over 1, down 2. And so you're going to have a graph that looks like this. And so this is, if I go 180 degrees, it's symmetrical around the origin, so this is going to be odd. When I plug in negative x, I get negative 2 times negative x cubed, but realize, what is this going to be? F of negative x equals negative x cubed, that's just going to be negative, and so this is going to be positive 2x cubed. So this is opposite, right? This is opposite of that. So when you plug in negative x, it's negative x. Okay, so this one's a little confusing because notice this one's negative here and this one's positive, right? And so they're opposite of each other, and because it ends up being opposite, this tells me that it is odd.